we're going to look at these more next week, but squares are a big part of quadratics because quadratics are something to a degree of 2, which means quadratics involve something squared. So today we're going to focus on solving or simplifying by taking a square root. So we are going to look at taking a square root of a value to get a solution. When a number is multiplied by another number that is the same number, then you get a squared number. When you multiply a number by itself, you get a squared number. Oh no. Have I asked you to make that? No. A square root is the value that the number you have under the square root. If it is not a perfect square, we are not simplifying. If it is not a perfect square, we are not simplifying. I do not want any decimal answers tonight. I do not want any decimal answers tonight. So if it is a square root that is not a perfect square, you are not simplifying it beyond taking the square roots of perfect squares. A radical is the name of a square root symbol. I'm going to give you the first 15 perfect squares. Radical. Your calculators have a way of looking at a square root, but they do not necessarily have a square root button. So on your calculator, if you are looking at your calculator, what you are going to do is hit the second key and then the x squared key. And that's going to put up the square root. And like I said, if it's a perfect square, like 16, you will get a whole number. If it is a non-perfect square, like 17, you get a decimal. So on your homework, I would want you to leave it as the square root of 17. If it is one of these perfect squares, then I want you to give it as the simplified value. If it is a non-perfect square, you leave it as the 17. The standard form of a quadratic is ax squared plus bx plus c. The form that we are going to use this method for looks like ax squared plus c only. The b value is 0, therefore gone. The b value is 0, therefore gone. Okay. So what does that look like as examples? So we're going to look at an example of each. If the A or K is negative once you solve, then you get no real solution. If the K value is negative once you solve, then you get no real solution. If when you solve you get x squared equals 0, then you get one solution at 0. Solution. There's a period at the end, not in between every one. Therefore, it is a shortening of a word, not a mnemonic device. It's not in the context of the problem. And then you can also get x squared equal to a number. If it is equal to a number, then you have two solutions. Those solutions are plus or minus the square root of whatever that number it is set equal to is. If that number is a perfect square, then you will simplify. In the case of 7, 7 is prime. We will leave it as plus or minus 7. So we're going to look at x squared equals 81. We're going to look at x squared equals 81 twice. We're going to look at the old way and the new way. So the old way, you would say x squared minus 81 equals 0. And then you would say, okay, that's a difference of squares, so I'm going to factor that. So it becomes x minus 9, x plus 9 equal to 0. And then you say, okay, that means x minus 9 equals 0, so x equals 9. It also means that x plus 9 equals 0. So x equals negative 9. That's the old way. That's kind of a lot of work. There's a shortcut for that now. And that shortcut says that if I have no b term, so again, x squared to a number, so no variable x by itself, then what I can do is isolate the x squared term. So I'm going to get x squared by itself, which it is. And then what I'm going to do is I'm going to take the square root of x squared. And when I take the square root, it gets a plus or a minus. So then I get, okay, the square root of x squared cancel. I get x plus or minus the square root of 81. 81 is a perfect square. You can always check it on your calculator. If you type square root 81, you're going to get 9. So you get x equals plus or minus 9. The same way I got x equals plus or minus 9 the old way. Yes.
So you basically just take the square root.
Correct. When you take the square root of x squared, the square root and the square cancel each other. Because a square root by definition means 1/2 power. So a power to a power is multiplied, so 2 times a half cancel. Technically, you could rewrite 81 as 9 squared whole 1/2 power. And same thing, it's where the 9 comes from. But that's next week. This week we're just looking at the square root of the problems that can be solved this way. Next week we're going to simplify square roots in more depth. So 2x squared equals 32. Is my b term 0? Because there's no x term, right? There's no x. So what do I want to do? I want to get x squared by itself. X squared and x are not the same. X squared and x are not the same. So we're going to divide both sides by 2. How do you get rid of something squared? Take the square root. When you take the square root, it becomes plus or minus. So you get x equals plus or minus. 16 is a perfect square. So we get 4. And number 3, do I have an x term? No. I have an x squared, not an x. So squared means power of 2. So I have a term with a power of 2, but I have no term that is just an x. Like this has 0 x's with no square. Like this and that are not like terms. So what we're going to do is solve or isolate x squared. So I get 6x squared equals 486. Divide by 6. I get x squared equals 81. How do you get rid of the squared? You take the square root. And I get x equals plus or minus 9 again. Number 4 kind of sets you up to be a trick. Because you have an x, but it doesn't show a square. However, you have something squared in the problem. So that one is a square root problem because you have a quantity squared. So once again, we're going to isolate the squared stuff. So we're going to isolate the squared stuff. So I'm going to divide both sides by 2. That leaves x plus 4 squared equal to 9. Now, is the squared stuff alone? Yes. So we can get rid of this squared by taking the square root. So that square root is going to cancel that square. That square root is going to cancel that square. That leaves x plus 9. So you on the left, you have that x plus 4, the square and the square root cancel. The 9 becomes a 3 with a plus or a minus. This is like our absolute value problems. Something is equal to a plus or a minus, so you have to split it. So x plus 4 equals 3, and x plus 4 equals negative 3. Solve for x by subtracting 4. And I get negative 1 and negative 7. Eighth graders can do this. I heard it yesterday. You can do this. I'm faithing. You just need to listen and copy and practice. Just a shortcut. I do the other way for this problem. You have to FOIL everything. Then factor.
Oh no, that's his freaking Friday.
This is what we're on the past.
This is one of my first probably about today. Three x squared minus 9 equals 0. Isolate x squared. I think at Monday you were teaching. And another test. Oh. 3x squared equals 9. Because you want to solve for x squared, divide by 3. X squared equals 3. How do you get rid of the squared? Take the square root. So x equals plus or minus the square root of 3. The square root of 3 is not a perfect square. Therefore, my answer stays as plus or minus root 3. My answer stays as plus or minus root 3. The last one is like the other one you did not like. You want to isolate the squared stuff. It doesn't matter if the squared stuff is a single variable or a quantity. So in order to isolate x squared, you're going to divide both sides by 4. We get x plus 4 squared equals 1. To get rid of that, you take the square root. So you get x plus 4 equals plus or minus 1. Because it's equal to a plus or minus, you have to make x plus 4 equal 1 and x plus 4 equal negative 1 so that you get your two answers for x, and we get negative 3 and negative 5. bottom four examples we're going to do tomorrow. So on your homework assignment, you're going to skip the top 6. So you're going to do everything in the gridded table, front and back.